Okay, the last class already we discussed about this unit. This unit was over. Now we just repeat this unit. Just revise the overall concepts of this unit. Okay, Laplace transforms and jet transforms. Right. So what are the topics involved in this unit? Are in Laplace transforms. Is introduction about the Laplace transform. Next, the concept of region of convergence. There is ROC for Laplace transform. Okay. Next, the constraints on ROC for various classes of signals. Next, properties of Laplace transforms. Okay, inverse Laplace transform. Relation between Laplace transform and Fourier transform of a signal. Laplace transform of certain signal using waveform synthesis, and some problems related to Laplace transform. Okay, these are the topics we have to discuss under this Laplace transforms. In the same manner, in jet transforms also we can discuss about the concept of jet transform, discrete sequence, region of convergence in jet transform, constraints on ROC for various classes of signals, inverse jet transform, properties of jet transform, distinction between Laplace, Fourier, and jet transforms, and some problems related to jet transforms, right? So, how the Laplace transform is defined? So, Laplace transform is defined as if mathematically it is defined as x of s. So, x of t is the given signal. So, Laplace transform of x of t, that is x of s, is equal to integral minus infinity infinity x of t into e power minus st dt. That is, we have s is complex variable or complex quantity, that is nothing but a combination of real and imaginary quantity sigma and omega. Sigma is the real quantity, omega is the real imaginary quantity. So here x of t and x of omega are called Laplace transform A. Okay. So Laplace transform of x of t is x of omega. So here we have two types of Laplace transforms: unilateral Laplace transform and bilateral Laplace transform, right? So what is unilateral Laplace transform? So it is integral is either from minus infinity to 0 x of t into e power minus st dt, or integral 0 to infinity x of t into e power minus st dt. That is a unilateral Laplace transform. Bilateral Laplace transform, it is varying from minus infinity to infinity, integral minus infinity to infinity x of t into e power minus st dt, right? That is the difference between unilateral Laplace transform and bilateral Laplace transform. Next, we'll see the relation between, we saw the relation between Laplace transform and Fourier transform. If the real part of the complex quantity, that is real part of the uh, complex variable, that is s, that is sigma is 0, then sigma, if sigma is 0, then s becomes j omega. So this is integral minus infinity to infinity x of t e power minus j omega t dt. So it is nothing but Fourier transform. So these two are related as a Laplace transform at s equal to j omega is nothing but a Fourier transform of x of t, right? Laplace transform at s equal to j omega is nothing but Fourier transform of x of t, right? So that is the relation between uh, Fourier transform and Laplace transform. Next, we will see the region of convergence. So how it defines the region of convergence of the Laplace transform is the range of values of sigma for which the equation integral 0 to infinity x of t mod x of t into e power minus st dt is less than infinity. Okay, it must be some finite value. So the range of values of sigma for which the equation integral 0 to infinity mod x of t into e power minus st dt must be less than infinity is nothing but a region of convergence. Okay, region of convergence. So next, we saw some problems. So x of t is e power minus at. So for that, t is greater than 0 means that is u of t into u of t. U of t value is 1 from t is 0 to infinity. So it can be written like this: integral 0 to infinity e power minus at into u of t into e power minus st dt. U of t value is 0 from 0 to infinity. So integral 0 to infinity e power minus of s plus a into t dt. By solving this, we can get two terms. So here we'll check the conditions. If s plus a is greater than 0, what will happen? If s plus a is less than 0, what will happen? So that we will take finite value only. If it is infinitive, we will neglect that. So we will take the finite value only. So in these two terms, Here we will get the finite value at s plus a is greater than 0. So 0 is the finite value. If s plus a is less than 0, then it will become infinite value. So here ROC is 1 by s plus a, and s plus a is greater than 0. If s plus a is greater than 0 means s is greater than a, and real part of s, that is sigma, is greater than minus a. Okay. So like this we can solve the problem, and also we have to draw the ROC, region of convergence, for this. So we'll take S plane. So S plane is combination of real and imaginary axis sigma and j omega. So sigma is the real part of S, and j omega is imaginary part of S, right? This is S plane. So S is greater than minus A. If it is S is minus A, beyond this minus A, we will get the ROC. This is nothing but our ROC. Okay, like that we'll do the problem. So next problem is minus of e power minus 18 to u of minus t, right? U of minus t is varying from minus infinity to 0. So from minus infinity to 0, its value is 1, right? Okay, so minus infinity is 0, minus of e power minus 18 e power minus h t dt. So this is minus of e power minus common s plus a into t dt. So by solving this, here also we get term a and term b. Okay, so if it is mm, if s plus a is greater than 0, or s plus a is less than 0, here s plus a is less than 0, we get the finite value. If s plus a is greater than 0, we get the infinite value, right? So here we will get the 1 by s plus a. If s plus a is less than 0, so s is less than minus a, or sigma is less than minus a. So we before minus a, we will get the ROC in s plane, like that. So this is a combination of two problems. Problem number one and problem number two. That is a numericals will be changed. So x of t is given as e power minus 2t into u of t minus e power 2t into u of minus t, right? So this is a e power minus 2t into u of t is above 1. E power minus 2t, e power minus of e power 2t into u of minus t, this one. So now we take the Laplace transform for this one. So like you get the ROC like this. So Laplace transform, by solving the Laplace transform, by we get x of s is 1 by s plus 2 plus 1 by s minus 2, and here the ROC is in between minus 2 and 2. So first of all, we will draw the ROC for sigma is greater than minus 2. So this is the first ROC, and next sigma is less than 2. So this is ROC. So this is the intersection point in between minus 2 and 2. These two ROCs will intersect, so that we get the ROC like this. So next, poles and zeros of Laplace transform. So here poles and zeros are represented. Suppose if you take a Laplace transform of x of t, that is x of s equal to numerator of n of s by d of s, where n of s is numerator polynomial of x of s to the d of s is denominator polynomial of x of s. So poles are nothing but roots of denominator polynomial, and zeros are nothing but roots of numerator polynomial. Okay, we can write this as we can write this as x of s equal to s minus z1 minus s into s minus z2 into s minus z3 by s minus p1 into s minus p2 into s minus p3, like that, s minus pn. So here zeros are roots of numerator polynomials, and the poles are roots of denominator polynomials, right? So here zeros are z1, z2, z3, z4, z5, like that, and zeros are Z1, Z2, Z3, and poles are P1, P2, P3, like that. Okay. For example, if we take x of s equal to s into s plus 2 by plus 5 into s plus s plus 3. So here zeros are 0 and minus 2, and the poles are minus 3 and minus 2. So next coming to the properties of ROC. So here we have six properties of ROC are there. Okay, these are all important properties. So these are, first one is the ROC of x of s consists of strips parallel to j omega axis in complex variable plane, that is S plane. This is so because ROC is dependent only on the real parts of S, that is sigma, thus the property, and ROC does not contain any poles. Third property is if f of t is a time limited signal and is Laplace transformable, then its ROC will be entire S plane. Okay, so delta of t is the time limited signal. Here we have taken delta of t is the time limited signal. So it occurs at t equal to 0 only. So its ROC is entire S plane. Okay, and if the continuous time signal x of t is right sided, and if the line sigma equals sigma naught is in the ROC, then all values of sigma for which sigma is greater than sigma naught will also be in the ROC. That is nothing but our first problem, e power minus 80 into u of t. So this ROC will be in the right side. Okay, and the right side sigma is there. Sigma is also present. Okay, and fifth property is the second problem. Okay, that is the CT signal x of is left sided, and if the line sigma equals sigma naught is in the ROC, then all values of sigma for which sigma is less than or equal to sigma naught will also be in the ROC. That is the second problem. E power minus of e power minus 18 u of minus t. So on that ROC, sigma will be present. And sixth property is nothing but a combination of these two problems. That is that was already solved. That is x of t equal to e power minus 2 into u of t minus e power 2 into u of minus t. So its ROC is in between minus 2 and 2. So like this we have six properties. Okay, right? Six properties. So like that, those are the important properties of ROC. And then find the Laplace transform of unit step function. So here we have done some problems. Okay, so unit step function is u of t equal to 1. Okay, right. Then find the Laplace transform of unit step function. So u of t is 1 for t is greater than 0, and it's 0 for t is less than 0, right? So it is varying from 0 to infinity, 1 into e power minus s t dt. So that is 1 by e power minus s t by minus s. So minus 1 by s into e power minus s t by solving this, we will get ROC like this. Like that, we will solve the RAM function also. X of t equal to t, t into e power minus s t dt. Like that, we get the ROC. Similarly, growing exponential e power 8 into u of t, already solved. Similarly, decaying exponential e power minus 18 into u of t. Okay. And sin omega t into u of t. Sin omega t. Okay. First of all, we will write the sin omega t in the form of sin theta equal to e power j theta minus e power minus j, e power j theta minus e power minus j theta by 2j. Okay. So in the same manner, e power omega t, j omega t minus e power minus j omega t by 2j. That is sin omega t into e power minus s t dt with varying limits from 0 to infinity. So by solving this, we will get the value of Laplace transform of sin omega t into u of t is omega by s square plus omega square. Well, in the same manner, you can do the cos omega t into u of t also. So here also we write cos omega t is cos j omega t plus e power j omega t plus e power minus j omega t by 2. Okay, so that we will get cos omega t is 1 by 2 into 2s by s square minus j square omega square, or it is s by s square plus omega square. Whereas sin omega t is omega by s square plus omega square, whereas cos omega t is s by s square plus omega square. Like that, you can do the problems e power minus of a into t. So mod t can be written as plus or minus t. If it is plus t, then it is e power minus at into u of t plus a. If it is minus t, then it is e power minus a into minus t into u of minus t. Okay, so that we will get e power minus at into u of t plus e power at into u of minus t. So that we can solve this problem. So that we will get the solution as x of s equal to minus 2a by s square minus a square, where if the ROC is in between R minus a and a, ROC is in between minus a and a. Okay, after that we have to do this problem. And then properties of Laplace transforms, we have 7 to 8 properties of Laplace transforms are there. Okay, so first one is linearity property, time shifting property, frequency shifting property, like this. So linearity means defined as the Laplace transform x of t is x of omega, and the Laplace transform y of t is y of s, x of s and y of s. Then weighted sum a into x of t plus b into y of t. Laplace transform a into x of t plus b into y of t is nothing but weight a into x of s plus b into y of s. A and b are some constants. And the next one is time shifting property. The Laplace transform of x of t is x of s. Then Laplace transform of x of t minus t naught is e power minus s t naught into x of s. So let the t minus t naught decay and t becomes t naught plus k. Dk is dt is d naught dt naught, that is 0 plus dk. Okay. So it is integral minus infinity infinity x of k into e power minus s t naught into e power minus s k into dk. So it is e power minus s t naught will be taken out. So e power minus s t naught will be integral minus infinity infinity x of k into e power minus s k dk, that is nothing but x of s. Okay, so therefore Laplace transform of x of t minus t naught is equal to e power minus s t naught into x of s. Next we will say frequency shifting property. So the shift of S naught in frequency domain is equivalent to multiplication by e power s t naught in t in time domain, that is Laplace transform of x of t is x of s. Then Laplace transform of x of t into e power s naught into t will become x of s minus s naught. Okay. So Laplace transform of x of t into e power s naught into t is equal to integral minus infinity infinity x of t into e power s naught into t into e power minus st dt, right? So it is equal to integral minus infinity infinity x of t into e power minus s minus of s minus s naught into t dt. This is nothing but x of s minus s naught, like the scaling property. So scaling property is Laplace transform of x of t is x of s. Then Laplace transform of x of a t is 1 by a into x of s by a. Okay. So let a t be t and t equal to p by a, or dt equal to p by a. So but a is greater than 0. So it is x of t for minus s into p by a into t by a. So 1 by a into integral minus infinity infinity x of t into e power minus s t by a into dt. So it is 1 by a into x of s by a. Similarly, k is less than 0, it is 1 by minus a into x of s by a. So in general, we can say that it is 1 by mod a into x of s by a. So integration time domain. So let me Laplace transform of x of t is x of s. Then Laplace transform of integral 0 to t x of t into dt is nothing but 1 by s into x of s. Similarly, differentiation is if Laplace transform of x of t is x of s, then Laplace transform of d by dt of x of t is s into x of s. Similarly, differentiation in time domain, that is the multiplication by t. So if Laplace transform of x of t is x of s, then Laplace transform of e power n into x of t is nothing but minus 1 whole power n into e power n into x of s by ds power n. Next, integration in s domain, division by t. So that is Laplace transform of x of t is x of s. Then Laplace transform of division by t, that is 1 by t into x of t is integral 0 to infinity x of s ds. Okay, next convolution property. So convolution in time domain will become simple multiplication in frequency domain. If Laplace transform of x of t is x of s, then Laplace transform of y of t is y of s, and Laplace transform of h of t is h of s. Then y of t is nothing but x of t converted with h of t. That is defined as integral minus infinity infinity x of tau into h of t minus tau d tau. So Laplace transform of x of t converted with h of t is equal to Laplace transform of x of t into Laplace transform of h of Laplace transform of x of t is x of s, and Laplace transform of h of t is h of s, and Laplace transform of x of t converted with the h of t is nothing but Laplace transform y of t, that is y of s, so that y of s will become x of s into h of s. Okay, so remaining derivation part we will see in the next class. With this I am concluding today's class. Okay, so